All right, before we dive into an example or two, just want to say a brief word about how to know if you have matched pairs or not. Granted, when you're doing the homework, if you're in 9-3, it's probably independent samples. It is independent samples. And if you're 9-4, it's matched pairs. But when you get to the test, you'll be looking at a problem and you'll have to figure out, wait, is this matched pairs or is it not? And more than the test, if you ever do this in real life, of course, it'll be up to you to decide. So, and it is up to you to figure that out. Just saying, is there some way that the data points in this set match the data points in that set? But I wanted to give you a few examples. Certainly before and after data, like the previous video, is a classic. Where you say, yeah, it's this person before and then this person after. You can also have data where maybe you measure the same people, like their left hand and their right hand, or their left arm and their right arm, or whatever. You can also do it where you're comparing maybe the reported data versus the measured data, like you ask somebody how much they weigh and then you actually stick them on the scale, right? And again, that data should be matched up by person. There's also a whole field of medicine and other areas where they do identical twin studies. And again, you certainly want to match up those twins. There's lots of other examples, and I certainly can't list them all, but I just want you to start thinking, hey, are these data points matched up? You know, if I just rearranged one list and not the other one, would that mess something up? Okay, let's take a look at a couple examples from the homework. Let's do number 14 first. So here you've got the blood pressure taken from the right and the left arms of the same woman. So theoretically it should be the same if her blood pressure is really the same. And then test for a difference between the measurements from the two arms. Okay, so we're really looking to say, we're really looking to get on the right layer. And then we're really looking to say, are the two means the same? Oops, or are the two means different? But we know doing this matched pairs, because this is matched pairs example, we'll really be looking to say, is the mean difference 0? Is there no difference? Or is the mean difference not 0? So notice you'll always use the same symbols. It's just the notation's a little bit different when you're realizing that you're talking about that list of differences. So we've got a null, we've got an alternative, and we have a significance level, which is enough to start driving stat disk. So we do want to be in the, here, let's start over. We want to be in hypothesis testing, and we want to go to mean matched pairs. And we want to pick the right alternative hypothesis. Our alternative is that the mean difference is not equal to 0. So it's just, is there a difference or is there no difference? So not equal to 0 is what we've got. Significance level 0.01. And I already typed the data in. Normally you'd have to do that. So type the data into a couple lists and make sure you don't have typos. That's always worth double checking. And we are going to compare column 1 to column 2. And let's go ahead and evaluate that. And the important part here for us is the p-value, which is 0.00006. And 0.00006. So if the null is true, this is a very unusual sample. So it's unusual, so we will reject the null. And we will say there is evidence that the averages are different. That the average blood pressure readings are different for right arm and left arm. Okay, something like that. That's it for 14. Let's try one more. So 16. Again, you look through this and you would say, is this matched pairs? And with a little bit of work, you figure out that, yeah, this is one person who they asked them how tall they were, and then they measured how tall they were. And this person said they were 68 inches tall. It turns out they're 67.9 inches tall. So yeah, this should be matched up, these two. And you can see most people fairly close. Somebody here like shrunk themselves by a foot. But anyway, they say construct a 99% confidence interval for the difference between reported and measured. So we're not doing a hypothesis test this time. We're doing a confidence interval. So we can go right back to stat disk. And this time we want a confidence interval. And we want mean for matched pairs data. And the confidence level, we forgot to check that, 99% confidence interval. So let's get 99% confidence interval. And just says which two columns would you like to compare, and I happen to have this data typed into 3 and 4 already. So I want column 3 versus column 4. You will spend a little time on your homework tonight doing data entry, but it doesn't take forever. It just feels like it takes forever. Okay, so let's evaluate this one. And the confidence interval is about -4.2 all round to 2.2. And what does that mean? Keep in mind that confidence intervals always talk about how much bigger group 1 is than group 2. Group 1 in this case was the reported height, and group 2 was the measured height. So you can say something like, on average, people's reported height, and keep in mind we want to make this sentence as user-friendly as possible, so I'm going to round even a little bit more here. People's reported height is anywhere from 4 inches less to 2 inches more, less or more than their measured height. And keep in mind this interval gives a range of values. So it says people's reported height could be 4 inches less on average, or maybe only 3 inches less, or maybe 1 inch less, or maybe 1 inch more, or maybe 2 inches more. Included in this range is the possibility that people's reported height is 0 inches more than their reported height. So again, we're not proving that there's a difference here. It could be that there is 0 difference. And if there is a difference, we don't even know if it's less or more. So that's when they're saying, interpret the resulting interval. So we just interpret it with this sentence. And comment on the implications of whether the confidence interval contains 0. So when you're talking about how much difference there is, if the interval says there could be 0 difference, again, the interpretation of that is just basically there could be 0 difference. There could be no difference. All right, go ahead and tackle that homework. We are getting so close to done. We only have a couple more sections.